Hello viewers, I'm Kausalya. Today we are going to discuss about state diagram. So the pictorial representation of the state model of the system is called state diagram. So as we all know what is meant by a state model, right? So here the diagrammatic representation of a state model is known as state diagram. So this pictorial representation can be either in the form of a block diagram or signal flow graph, right? So this state variable, that is this block diagram as well as the signal flow graph, they describes the relationship among the state variables, right? And here there are two types of state diagram. One is time domain and another one is S domain. So here time domain, here the diagram can be obtained from the differential equations governing the system, right? From the differential equation we can draw the time domain diagram. Here this state diagram can be obtained from the transfer function of the system, right? So transfer function is nothing but it is Laplace transform of output to the Laplace transform of input with zero initial conditions, right? And here this differential equations we all know, right? That is we will be having three basic elements: mass, spring and dashpot, and we will be writing the force balance equation, and finally we will be representing it in the form of differential equations, right? And here the time domain diagram is used for simulation of system in analog computers, right? In analog computers this is most commonly used, whereas this state, that is S domain state diagram, they provide the relationship between the time domain and S domain. As we all know, whenever you take Laplace transformation of time domain, that will be, then the corresponding answer will be in S domain, right? And the next thing is we are going to discuss about basic elements. Here there are three basic elements. The first one is scalar. So scalar, as we all know, they are nothing but a constant. So here you see, here A is a scalar and here this x of t is a signal. So what will be the output? We have to multiply these two elements. So the final output is A into x of t, right? So this is a scalar. And the next thing is adder. So adder, as we all know, it is used to add two or more signals. Here, in other words, output of the ladder is the sum of the incoming signals, right? Both are same. So adder is used to add signals, that's it. And the next one is integrator. So here it is used to integrate the signal, right? So here you see they are used to integrate the derivatives of state variables to get the state variables. Here don't get confused. You see here, for example, let the state variable here is x dot of t, right? So if you integrate this x dot of t, what happens? You will be getting the answer as x of t, right? Because here this dot represents differentiation and here it is integration. So they both cancel each other and finally we will be having the answer as x of t, right? So this is what mentioned here. Integrators, they are used to integrate the derivatives. So derivative is nothing but differentiated form, okay? Derivatives of state variables. If you integrate the derivatives, you see here, if you integrate the derivatives of state variables, what will be the answer? We will be getting the state variables. Can you get what I am trying to say? So derivatives of state variables is nothing but x dot of t, right? Here integrate. We are integrating this x dot of t. So what happened? In output we will be having the state variable which is nothing but x of t, right? The next thing is elements of block diagram, right? Now we are going to represent it in time domain and S domain. First one is scalar. So here, as I already said, scalar is nothing but a constant, right? So here A is a constant, time domain, so everything is in the form of t. So x of t is the input signal. So what will be the output? It is A into x of t, right? In S domain, again the input is x of s, therefore the respective output is A into x of s, right? And the next thing is adder. So here adder is nothing but we will be having a summer always, right? Either it is a addition or subtraction. So here we are having a summer and these are the two input signals, x1 of t and x2 of t. So the output is both are with the plus sign, right? So x1 of t plus x2 of t is the respective output. So here when you look at this S domain, again x1 of s and x2 of s are the two input signals. Therefore the respective outputs are x1 of s plus x2 of s, right? And the next one is integrator. So integrator, again you see here the input is x dot of t. Okay, we are integrating and the output is given to a summa with the plus sign. And again the other input signal is x of 0, again with the plus sign here, right? So what will be the respective output here? So here you see that is integration of this x dot of t will be done, right, with respect to dt. So integration, the limits are 0 to t, x dot of t into dt plus this symbol x of 0, right? And the same thing in the form of s, you see here it is x of s and here 1 by s, right? And the corresponding output is again given to a summa with the plus sign, both the cases. And here you see the another input signal is x of 0 by s. Since we are representing in s domain, okay, here we are including the term 1 by s here, that's it. So here the respective output is x of s by s plus x of 0 by s, right? Then the next thing is elements of signal flow graph. So here again we will be having the same basic elements, scalar, adder and an integrator. So again here, since signal flow graph, we are going to discuss it with the help of nodes. So you see here we are having two nodes, right? And here the input signal is, the value is x of t, and here a is a scalar. Therefore the output is a into x of t, right? Again in s domain, x of s, a, and the output is a into x of s. And the next one is adder. So again we need two signals, right? Either to add or subtract. So x1 of t and x2 of t are the two signals. And here the output will be, that is we have to add. Therefore x1 of t plus x2 of t. And again, so here also that is a node, right? And here again in terms of s, so x1 of s, x2 of s, therefore the output is x1 of s plus x2 of s, right? And the third one is integrator. So here the same thing happens. You see here we are having x dot of t and here integration takes place. So when x dot of t is integrated, what happens? The output is simply x of t, right? And here we are having x of 0, so plus x of 0, right? And the next thing is again you see x of s, right? So since in time domain here we are introducing 1 by s here, so 1 by s. So here the output is x of s by s and here plus x of 0 by s, right? The next thing is the state model of linear time invariant system is given by this equations, as we all know, right? So x dot of t holds for state equation and y of t holds for output equation, right? And the next thing is block diagram of a state model. So how to represent the block diagram? So here you see this is a representation of state model in block diagram, right? So okay, look carefully. We are going to frame these two equations in the form of block diagram and signal flow graph, right? So the first thing is, you see here I am having b, right? And the input is u of t. Okay, this u of t is fed to b as well as d, right? And here again the output from this b block is given to a summa, right? And the output from this summa is x dot of t, which is given to an integrator, and therefore the output is x of t. And this x of t is given as feedback to this block A. Therefore here again the output will be a into x of t, right? Am I making clear? Then the next thing is we are having C, and again output is given to a summa, and again the output from this D block is also given to this summa, and here we are having the output, the response, that is the output representation y of t, right? Here the input is u of t and the respective output is y of t. So when you look carefully, you see we need x dot of t, right? So here is our x dot of t. So x dot of t is nothing but we have to sum these two values that will give the x dot of t, right? So here what is the output which is coming from here? Sorry, what is the feedback part here? So x of t which is given to a. So the output will be a into x of t, right? Do you agree? Here is x of t. This x of t is given to both c as well as a. So when it is given to a, the output is a into x of t. And here what happens? This u of t is given as input to b. So the output is b into u of t. Right. So here the output x dot of t is nothing but a into x of t plus b into u of t. This is our first equation. Right. Then we are proceeding with the second equation. So here it is y of t, right? So y of t, here we are having a summa. So again, here what is the input? Here c into x of t comes here, and again u of t into d, right? So this part has the output of d into u of t, and this part has the output of c into x of t, right? Therefore, the final y of t is nothing but c into x of t plus d into u of t. Right? Next thing is we are moving to signal flow graph. So again the same thing, right? So here we are having totally 4 nodes, right? One is input node, another one is output node. So in between we are having this x dot of t and x of t. That's it. So again here it is, that is the feedback part. Here it is a, and this in this feed forward path we are having d, right? Again between you see u of t and this x dot of t, that is a b, right? You see, even you can convert this block diagram to signal flow graph as well. This is also an easy step. So we are having u of t, x dot of t, x of t, and finally y of t, right? So this is the thing which is represented here. And between u of t and x dot of t I am having b, and again between this x dot of t and x of t I am having an integration, and between this x of t and this y of t I am having a c, right? So again the same case, here a and here in this feed forward path it is d. So finally the state model is represented in the form of block diagram, right? And as well as the form of a signal flow graph. So here comes the end of the topic. If you have any doubt, let me know in the comment section. Thank you.